Alright, let's get right into this. Another week, another assignment, another summary. So this is topic stuff. We're now actually getting into the part of this learning pack where we're at the hardest part of the first year. This is the first bit. So parametric equations, they're fine. I mean, they can be fine, they can be difficult. Usually, they're like a mid-end of paper topic. But they can definitely like confuse people a lot. The differentiating part isn't that hard. And then the normal distribution, very so after this we're going to be basically done with stats. All we have to do after this is hypothesis testing with the normal distribution, which for some reason is left in a different week. But that's like one lesson, so we're basically done with stats after this, thank God, because I'm sure not many of you enjoy stats. And sometimes they can put hard questions on this up, but usually it will just be a hypothesis test or like putting in your calculator or something like that. But anyway, let's go straight to the assignment. So, starting with some integrals, we got some nice warm-up here. So, integrate, substitute. I mean, there's nothing much to say here. Integrate, substitute, integrate, substitute, integrate, substitute. Just remember to write out your limit calculations like here. Don't do what I did here and just simplify instantly because I could not be bothered to write a lot of stuff down. This question was interesting because it doesn't really say. Usually in the exam they will give you a diagram for something like this. But what the area that's asking you for is this area here. This like the area in between the curves. So you set them equal to each other, find the points of intersection, and then integrate the function. So x squared minus x squared plus 4 is just when you rearrange this to make it equal 0. That's the function that you get. And you just integrate that because if you remember from when we did integration year 1, when you're finding the area in between two things, it's just the upper thing minus the lower thing. So it's the parabola minus the line. Next thing, we have this question. This is a bit annoying. Yeah. I was thinking of lots of different ways to do this, but the best way I came up with was saying that the line that it's asking for is 2x plus c. There's going to be two different values of c because there's two different tangents, and so you just substitute 2x plus c into the equation, and then you say that because they're both, it will be don't get confused by the fact that there's two lines. It's going to be both the lines are going to have one solution, so it's going to be the discriminant equals 0, and then you could solve for c, and then you write both the lines out. Next, we have some vectors in mechanics. So here, the velocity, you just do the rate of change of the thing. So the change is, it's saying that. Sorry. The velocity is going to be the change in displacement over the change in time, which is the change in time is 2.5 hours, and the rate of change of displacement is this minus this. I don't know why I wrote equals 2.5t. It should just be over 2.5, and then you can divide and get your velocity. Expression for b, well, this is like common, so r equals r0 plus vt. Write it down. Next, given that c intercepts v, find the value of lambda. The reason why it says that given that c intercepts b, that basically means that like the equations, they're telling you that the value of t will be the same, so you can substitute it back in. Because if they don't intersect, then lambda it won't work. So you don't have to worry about the fact that it says that they intercept each other. You just do the normal method of setting them equal to each other. You find t and then substitute that into the other equation. So you resolve your I components, find t, resolve your j components, substitute t in, and then you get lambda. Oh yeah, so there was probably an easier way to do this question. So given that they intercept, show that before they intercept, they're moving at the same speed. So what I did is I said that I differentiated both of the equations with respect to time. So it only leaves, so here it just leaves the time, because the constant goes away and then all the things behind time just the time gets goes, and then it just leaves this vector here, because that's what when you're differentiating vectors, it's the same as normal things, and same with the other equation, and then I found the modulus of both of them, and they both equal each other. So the speed is not there's no distance involved. No, sorry, there's no direction involved with speed. So we're just looking at the magnitude. Right. Next question. This is another question where I probably overcomplicated it. What you could do here is you could just say that definitely the way that you should be doing it is you draw this triangle out, you say that sine 2a is 2 sine a cos a. You find that sine a is going to be root 7 over 3. No, sorry, root 7 over 4. And then you just do 2 times that times cos a, and that's the easy way to do it. I use T formulae, which is something from next year, but I don't know. I was just practicing my my further math stuff. Then, but the crucial thing at the end, you're going to get this answer through root 7 over 8. But you say because it says that this is the crucial information, so you draw out the value of sine a, and you just say that it's going to be negative in this interval. So yeah, it's going to be fully negative in this interval of sine a, which means that it's going to be negative the entire thing. Actually, I think this should have been this is not what sine 2a looks like, but it would still be negative for the entire time, so don't worry. If you were to draw out sine 2a, it would look something like that, and it would definitely be, it would be like this, and then it would go under, like that. But you can track that on your numworks if you want. But that's, if you're wondering why it's negative in the answers, is because the graph of sine 2a will be negative for this entire interval. Also, that's not even the correct interval, even on this graph, so I kind of just locked out with that one. So this is just another. You could prove this with symmetry, but I just expanded it and rearranged, and then it worked. Next. Oh my god, did I do it again? Yeah, I did the thing where I forget to do a question. Well, so what would you do here? So this question, you simplify this to cos 2x, differentiate, and then it will simplify to this. Yeah, that's pretty uninteresting. Right, this next question. Variable acceleration is not. It gets very repetitive because they just give you the same functions. So it says that it starts from rest, and we know that acceleration is gonna be 0 because the starting acceleration, and then the starting velocity is also gonna be 0 because it starts from rest. And that this means that also, because when you're integrating a polynomial, or like any term in a polynomial, there'll never be a constant term. So when you substitute this stuff back in, the plus c is always going to equal 0. So you don't have to worry about any of the plus c's in this question. Obviously, you could do it yourself and naturally substitute and then find that they all equal 0, but it's just a thing of things you have to notice. So finding the velocity, you integrate, blah blah blah, and then you integrate again to find the displacement. Next, we have this question. Velocity in terms of t. So you have to integrate going from acceleration to velocity, and then you get a plus c. It tells you here that it's initially 25 meters, and it's 7.5 meters per second when t equals 0, so c is just going to equal 7.5. And then you integrate again to find distance, find your c value, which is going to be 25, and then you have your full equation here. And then you substitute values in for this last part. Right, next, these are interesting questions. So what I've done here is I didn't want to draw out all of these graphs because sine y and arc sine x are similar graphs. So y equals arc sine x looks like that, but I added dotted lines onto the ones so x equals sine y actually goes on forever. It's just x equals sine y is just y equals sine x rotated 90 degrees. So it goes on forever. Same with this one. Same with this one as well. So yeah, now after this, just also you have to remember the graph shapes for like arc cos, arc sine, arc tan. Next we have this transforming the arc cos graph. So you moves up and stretches a bit. Next, this just moves left by pi. This one stretches in a bit and also moves down. Right, I messed that one up. That's right. I is not right. That one's supposed to be moved. Oh no! I did it. What am I talking about? That's. Wait, what? What did I do? No! I did do it wrong. It's supposed to go it's supposed to intersect the x-axis at 1, 0, not whatever I put there. And then this one is just. I didn't really understand this one, so I just put it in the calculator, if I'm being honest. I don't really know why this looks like it. It also, it kind of cuts off. So, I mean, I guess you could kind of figure it out by testing like endpoints and stuff, but you have your calculator for a reason. Right, anyway, next. You have this again, so we have another variable acceleration question. Integrate, substitute, find your C value, and then substitute. It's really not very interesting. This question, you just say that. So we say when you do inverse trig is actually quite a hard topic, and it's never come up before, so we don't really know how hard it would actually be when it comes up. So they kind of estimate the difficulty, and a lot of the questions that get really hard for inverse trig. So for this question, for most questions, you should either use right angle triangles, or you should set your inverse values to like a dummy variable like a, b, u, whatever. And then so you can do this. So you have arc cos x equals a, and then you can cos both sides to get x equals cos a, and then I've squared both sides, added 1 to both sides, and square rooted both sides to get root 1 minus x squared equals root 1 minus cos squared a, and then you can, after that, you can just say that because root 1 minus cos squared is just sine, and then you can arc sine both sides. You get this arc sine of that thing is a, which is the same as arc cos. Next we have, what do we have next? Why it's not true for this. So they gave a different reason, I think, in the answer, but this reason still applies. If it was negative, you wouldn't. So I've actually just done a little bit of a skip here. So this would turn into sine squared and then root to make sine. But in the step of turning sine squared x into sine, it wouldn't work because sine squared would be negative sine squared a. So you couldn't square root it. Therefore, it's not true for this value. Right. We haven't had a projectiles question in a while, actually. Maybe you've had it on your assignment tests, but they usually put like 1 per assignment. Maybe they skip it sometimes. This is just some like general cases. So you put all your these are just testing like what you know about projectiles and like what values are which. So obviously you say u cos alpha, u sine alpha. This is the same because acceleration is 0, and then vertical acceleration is negative g. Time of flight is just going to be 2 times the amount. So when it's at its peak, so when final velocity is 0, it's just going to be 2 times that, because it's not being launched from like a height. So it's going to be like when it's at its peak, that's going to be half the time. So if you multiply that time by 2, it's going to be the total time of flight. So if you just say you set final velocity vertically to be 0, do v equals u plus at, and then solve for t, and then you can multiply it by 2. So that's going to give you the total time of flight. Now we have the range of the projectile. So now we say that the same thing. So the total range is going to be 2 times the... Actually, no, we can just say that... Because this is the total time of flight. So you just do s equals ut because a is 0. S is just r. And then... oh, Jesus. Where t is the total time of flight, which you just calculated. Put this on the numerator, use your double angle identity on it. You get your r value, or not really a value, just an expression. And then you say that 2 possible values, so given that r equals that, find 2 possible values where it could have been launched. C. Show the greatest possible range is when alpha is 45, where you just say that the greatest possible value of sine 2a is going to be, so u is fixed, so we don't have to worry about that. G is a constant, so the only thing we're changing is sine 2 alpha. So the greatest value of sine 2 alpha is 1. So that's the greatest value of sine ax or like anything alpha. It's going to be 1. That's going to be the greatest value. And that means so sine 2 alpha equals 1. And then from that you can solve, say that alpha equals, or 2 alpha equals 90, because sine 90 is 1. So alpha is going to be 45. Next we just literally set them equal to each other because it's saying that we've already shown that r is this, and it's telling us that r is this, so we're just trying to find alpha. And you get these angles. Right. Very boring thing. If you just remember how, for this first one, or maybe for the first part of both of them, you can do it manually. maybe like log both sides and then rearrange it and then find your values. But you can just kind of remember that for polynomials, this term here is going to be your gradient, and sorry, no, this value here is going to be your y-intercept, and this power is going to be your gradient. So same thing here. And then for these ones, log of this number, log of the base is going to be your gradient, and then log of the thing is going to be, this thing is going to be your y-intercept. Yeah, I'm not having a very good time with my voice today. We have, this is really easy. We just, if these two values equal each other, we just use the binomial formula, which is in the formula book, and then solve for p. Really not that difficult. Next we have some proof. So this is kind of like a classic exhaustion kind of thing. So we say that we have this, case 1 n is odd, and you find this, and oh, Jesus. And basically what I've done here, to prove something's a perfect square, you have to say that this should factorize to something, like some like term, all squared, so like, I don't know, 6m plus 4 all squared, which, because this quadratic has no solutions, it will not factorize into anything, therefore it can't factorize into this form, therefore it can't be a perfect square. Alright, here we have a kind of a repetition of what we did I think it was last assignment, where we were differentiating and integrating all the stuff. Differentiating is really easy. It's literally the exact same as the sign, except the signs and causes are switched and it's negative. For the integration, again, it's pretty similar. So obviously A is easy. B you just turn into 1 half plus half sine 2x and then integrate. For odd powers of cos, you turn cos squared. You separate cos and cos squared, turn the cos squared into 1 minus sine squared, and then you can do this one using normal standard results, and then this one with reverse chain. Then when you have even powers of cos, just like B, you use the double angle formulae. So here you're going to expand to get this, but cos squared 2x, you can just turn into cos 4x's, and then you can integrate that. And then obviously with odd powers of cos, like I said for this last question, you turn all of the causes except one of them into 1 minus sine squared, and then you'll be left with one individual cos term, and then the rest of them will be sine to something power cos, and then you can just use reverse chain rule and remove them. Right, B. Lot of long questions in this part, if I'm being honest, so I'm just going to kind of speed through it because it's a lot of just work that we have to do. Implicit differentiation, find the stationary points, highest and lowest points, that's just what that, because this is an ellipse, so you have to, the highest and the lowest points are just the two stationary points. You differentiate both sides, do your implicit differentiation, solve. Stationary points is when the dy by dx is 0, so you just get x equals negative y over 2, and then you can substitute that back into the original equation and find x and y. Next question, same thing, implicit differentiation, solve, find the equation of the tangent, and then flip it negative to find the equation of the normal, use y minus y1 equals mx minus x1, and then rearrange, you get your equation. Next, in partial fractions and algebraic division, I am terrible at both of these, but I managed to get through. Divide, find your remainder, put it in this form, and then integrate. Just remember, whenever your thing on the denominator is an x, and there's no other thing on the fraction, you have to learn it instead of doing your normal power rule stuff. Because if you add the power by 1, it will turn into x to the 0, which doesn't make sense. And then these terms are just power rule. Next question for factor theorem. You just, again, for these types of questions, if it's in the exam, you should actually substitute the thing in and then say, therefore, factor by factor theorem, but I'm lazy, so I'm just going to do it like that. Next, we have another factor theorem question. So we're going to... Or no, next we have to put this in partial fractions, sorry. So you put it into this form, and then I pre-multiplied the denominators, and then you can fully expand this and like factorize your terms and stuff, but I just kind of see like when I expand this, what's going to happen to the x squared term, where it's going to be 9a. What's going to happen to the x squared term here? It's going to be 3b, and then what's going to happen to it with a c, where it's going to be no x squared term. And you just do that for all of them, and then you eventually get your values. You get the 3a equals b, and then you can substitute that into both of the other equations and try it until you find your values. Next, integrate again. So this is just more lens, more of some reverse chain rule, I think. Yeah, we have from reverse chain rule on this fraction here. And then just lens on the other one. I should have actually combined these lens. Next question, we do a similar thing. You divide, put it into partial fractions. I use the cover-up method here. I've explained that in a couple of previous assignment videos. Comment if you want me to explain it again. I can't be bothered right now. And then you can integrate this again. I did the power terms first, the normal terms first, and then you put the learn stuff together and moved it all to the power just to like keep it a bit clean. Next question, there was a very similar question like a couple of assignments ago on this stuff, like where f of x is greater than g of x, f of x is less than g of x. So for your sketching, find the coordinates of points of intersection, you set them equal to each other, factorize, find your x values, and then substitute them back into the line or any equation. Finding set notation, so if you just look at the graph, you can see that it's going to be before here or after here, whether the parabola is higher than the line, and you just put it in whatever form of set notation you can. There's a lot of different ways you can write the set notation. It's not just the ones they write on the answers. So this is another. So they use like some weird thing in the answer, but this is how I write my set notation. Next, anyway, we have some. We haven't had binomial expansion in a while actually. Use some nice. What's the name? Aesthetic working here. So first three terms in ascending powers of x, you just write out all your stuff. So one term, term, like binomial coefficient term, binomial coefficient term. Like so you do both your terms and the binomial coefficient. Just remember that something choose 0 is 1, so don't worry about putting 8 choose 0, and then anything choose 1 is just that thing, so 8 choose 1 is just 8. And then after that, you can start using a calculator for the choose function. And then you can write out your stuff here. Now for this next question, given that these coefficients are these things, find the values of a and b. Well, I wrote this out, this binomial out. You don't need to worry about any other term above this because we're only looking for the terms of x squared and x. And if you look at this a plus bx, nothing. If we have an x cubed term in this original thing, it's not gonna none of the terms. The x cubed term isn't gonna turn into x or x squared from this binomial from this term here. So you write this down. You say that well, all the blue arrows, the blue arrows multiplied together are going to give x squared terms. The red arrows multiplied together are going to give x terms. So all the x terms, all the coefficients of the x terms add together to make that number there, and then all the coefficients of the x squared terms add up to make that. So and then you solve simultaneously. And when I say solve simultaneously, I mean put it in your calculator, and then you get the answer. Next, some differentiation. So this is some like product, chain, quotient, stuff like that. So this is all just chain rule. Actually, no, the last one's product. So, so for this one, you have to remember your standard result for sec. It is in the formula book, so don't worry that much. But you multiply by the inside function, and then you get the outside function. Same with this one. Multiply by the inside multiply by the derivative of the inside function. Next, you do some product rule on this one. Jesus. This one for. My God, man, I need to take a break. Oh my God. Alright, it's fine, guys. I'm dying, but I'll still make the video. So for this one, you just do 1 over whatever it says here. So 1 over the derivative of this, 1 over the derivative of this. You just use some product rule. 1 over the derivative of this. You should be factorizing this in the exam because they'll usually make you do stuff with this, which you need to factorize to do. But it didn't tell you to factorize in this question, so I cannot be bothered. And then for part C, you just use quotient rule. I'm not going to go through all this. It's just quotient rule. Alright, next part. You find the derivative. Here, this is what I'm talking about with the factorizing. So when you factorize this, it will turn into this. The e to the negative 2e to the 2x. Negative 2x is never going to hit 0, so you can get rid of that. And then you have cos 4x plus 2 sine 4x equals 0. And you can rearrange that to find that. Right, on to the We haven't had any applied actually yet, which is nice. But we're getting on. Oh my god, we're getting onto it now. So this was actually an interesting question because it was a lot easier than it sounded. You know that whenever you have a system that's in equilibrium like this, the tension is just going to be the mg of this here because there's no external forces. So and they must be equal to each other. So this is mg, this is mg, this is mg, because the unknown mass is the mass of B. You draw your forces down and you just put the mg equals 3g sine 37 and then solve. It's actually a lot easier than it looks. You're, by the way, you're resolving parallel to the plane here. I didn't write the equations of motion, like the equation of motion, like what's it called? Notation. Next question, we have a binomial distribution. Yeah, just put the stuff in your calculator. You get it. That is not supposed. What the hell have I done there? That's supposed to be px is greater than. Wait, what? I don't really know what I've done there, but it should be that, I think. It should be x is greater than or equal to 3. But I don't think that's even... I don't care anyway. Hypothesis test. Yeah, we've done... This is just the reality of assignments now. We're going to have to start doing hypothesis tests, unfortunately. Null is that it's 0.1, which is the same, and then it says that... well, just if you're thinking about the situation, I mean, realistically, it's going to be that, like, the hypothetical person in this thing is it's going to be, they're saying that it's a scam, so it's going to be less than. But you can just read the thing. Pub landlord notices that their customers only found 2. Gives evidence of there being fewer, so this is lower tail. Then you put your distribution down. I've always do p-value, and you can. I'm going to say it's every single time there's a hypothesis test in a video. And then you can do your little conclusion. There's these like mini hypothesis tests that I'm doing. You should definitely like say what your variable is, do a better conclusion statement, stuff like that. But I'm not trying to do that for every hypothesis test. This is actually my first time ever doing one of these questions because I wasn't in for any of the lessons we were doing them. So and we never had one of these on the assignment before. These like simple connected particle style questions. So I kind of just had to wing it. All I really remember is you're supposed to resolve separately between the whole system and one of the things. So for this one, finding the acceleration, you just do resolve the entire system because the tensions are going to cancel. If you resolve just one thing, the tensions are going to be in the equation, which you don't want. So you resolve the entire system, get the acceleration, which is going to be the acceleration of both of them, like if you split it. So then you resolve the trailer, you get this, and there's your answer. Next we have some of this. So now we have to do a new equation of motion because there's no more there's no more tension. So you have to do a new equation of motion, just resolving for the car, finding your new acceleration. It tells you that u is 12. It tells you that t is 4. You get your acceleration, and then that's how you find your distance. For part D, for whenever it says about stuff being inextensible, it's either something to do with tension being constant or tension being the same at both points. So in this mark scheme, I wanted you to say that tension is constant from the car to the trailer. But this probably works. Next, we have question 12. Question on some more, literally the exact same thing, but just more work. So draw your little diagram. Find normal reaction force, just because why not? I mean, we need it for this anyway. Resolve parallel to the plane now. You do all this, do your F net equals ma, and then solve for A, and that's going to be your answer. Thank God it told you, like it was to show that question. Again, inextensible, saying that t is constant, the acceleration at one point is the same as the acceleration at another point. And then magnitude of the force exerted on the pulley. I don't know if many of you have done this in class, but whenever you have this specific question, it's always the thing to remember is 2t cos theta over 2, where this is theta, because we're looking on the force exerted on the pulley. So it's always 2t cos theta over 2, and then you just put that in. So theta, because theta is going to be 60, because you're doing 180 minus 90 minus 30, and then 60 over 2 is 30, obviously, and then you put this in. Alright, next we got another hypothesis, or two more hypothesis tests, actually. So here you need the formula book this time. You can't remember these values, unfortunately. So I'd use rho instead of p. That can, if you have a strict examiner, they can dock you a mark on that. Always remember to see if you're doing a two-tailed test or not. So this one is a two-tailed test because so investigate that there is a correlation. It's not that there's like a positive or a negative correlation. It's just a correlation. So its rho is just not equal to 0, not greater than, not less than. Read your sample size. Your significance level is going to be half because it's a two-tailed test. Look at the formula book. Get your critical value. I drew out the little diagram just to help. This is the critical region. And you say your test statistic is in the critical region, therefore you reject null hypothesis, and then you do your little conclusion. I sent this one out as a like kind of example of what to do, and then this next one I just rushed it. So the only difference with this one is that rho is greater than 0 because it says that there's a belief that in general cars get faster as they are further from the junction. So rho is greater than 0 is what we're testing. Next, this was. This is a question that I just completely copied, really, because finding PM. I mean, I don't really know what they expect you to do, and like, it's definitely quicker to just look at the answers instead of calculating PMCC with your calculator. I don't think anyone can be bothered to do that. Next part, just say that they're extrapolating, which is unreliable. Measured, that's just the degree of linearity between the two variables, and then you do the test. Blah blah blah. Oh yeah, no, this test is actually hilarious. So I don't really know what they were expecting here. I don't know if they meant to say that the population coefficient or the population thing is greater than 0, because we're testing that PMCC is greater than 0, but we have the PMCC based on like what we just found up here. So reject H0 because we know what PMCC is. So yeah, I don't really know what that's supposed to be. When was this data collected? I mean, it says right here. So yeah, I don't think that's very hard. And then no one can be bothered to do part B. I don't really know what it even means, clean the data, because that's never going to come up. Same with this, I'm absolutely not finding the modal value for every column. And then difference with this is like probably one of the most important things to know about the large data set. That trace is rainfall that is less than or equal to 0.05 millimeters. And that is the end of my sick assignment completion video. I'll see you guys next week. I wish you good luck on the stuff that we're doing over the half term because it's going to be some hard stuff. And I'll see you next time.